students, good morning. In previous class already we discussed about the drawbacks of Rutherford model of atom. Okay, so what is the drawbacks of Rutherford of model? Okay, model of atom. Today we discuss about the development leading to the Bohr's model of atom. Which development occurs? Okay, what is the main developments? Okay, by the Rutherford's. Okay, sorry, Bohr's model of atom. This development occurs. Okay, results observed from the studies. Okay, after the study, okay, we observe them what of interaction of radiations with matter have provided immense information regarding the structure of atoms and molecules. According to the after the observation, many types of structure and matter wave. Many observations are occurred. A large amount of immense. Understand? So Niels Bohr utilized these results to improve upon the model proposed by Rutherford. Niels Bohr. You know what? Bohr's model of that is known as Niels Bohr. Utilize these results to improve upon the model proposed by Rutherford. So that's given by the Rutherford. He also improved. He given the another postulates. Over the Rutherford's model of atom. So two developments. How many developments? Two developments. Two developments played a major role in the formulation of Bohr's model of atom. Which formulation by given by Rutherford? Sorry, Bohr's model. First, what is the first model? Dual character of the electromagnetic radiation, which means that radiations possess both wave-like and particles-like properties. According to Bohr's model, Niels Bohr proposed by improve that's given by the Rutherford. He improved the that models. First, what is given? Dual character means क्या? Dual character of electromagnetic radiations. Electromagnetic radiation of dual character. इसमें दो character होते हैं, द्वि. Which means that radiations possess both wave-like and particles-like properties. Means electromagnetic radiations have both dot-like character, wave-like properties and particles-like. Means both have them. This is the wave and particles both. Understand? Second properties. Experimental results regarding atomic spectra. This is the experimental results regarding atomic spectra, which can be explained only by assuming quantized electronic energy levels in atom. Quantized means fixed. What is the quantization of? The experimental result, what finding? Atomic spectra which can be explained only by assuming quantized. Quantized given. That is electronic energy levels in atoms. What is the electronic energy levels of atoms? So these are two explanations given by the Niels Bohr. Understand? That is the improvement over the given by Rutherford. So now we'll discuss about what is the wave nature of electromagnetic radiation. Do you know about just we have discussed two types of given by wave nature and particles nature. By the electromagnetic. So first we will discuss about ki wave nature of electromagnetic radiation. Ki wave nature kya? What is the wave nature of electromagnetic radiations? Understand? So first we'll discuss about James Maxwell. In 1870, was the first to give the comprehensive explanation. James Maxwell. First give the comprehensive explanation about the what? Interaction between the charged bodies and the behavior of electrical and magnetic fields. He given the explanation about the interaction between charged body. What is the interaction between the charged body? Charge means you know about now. Suppose there are two body Q1 Q2 charge. Understand? Just we have discussed now. So two bodies have Q1 and Q2 charge. What is the interaction between two bodies? And behavior of electrical and magnetic field on microscopic level. After the when we applied electrical and magnetic field. What is the case of on microscopic level? So he suggested that when electrically charged particles move under the acceleration. When a charged particles moved under a electrically charged particles move under a acceleration. So alternating electrical and magnetic fields are produced. So what happens after that? Alternating electrically and magnetic fields are produced and transmitted. और वहाँ से क्या होती है? Transmit. Release. So these fields are transmitted in the form of waves, and these are transmitted in the forms of waves called electromagnetic waves या electromagnetic radiation. Understand? So after the applying a when what happens? When the charge electrically charged particles move under the acceleration. You know about this is also electron. Electron is also charged particles. When we revolve around the nucleus in a fixed part of fixed orbit, that is क्या है? Accelerating occurs in that circular path. तो देन आप व्हाट ऑब्टेन कि इलेक्ट्रॉन्स आल्सो एमिट द है ना रेडिएशन या एनर्जी. तो इन द सेम वे कि when electrically charged particles move under the acceleration, the alternating electrical and magnetic fields were produced and transmitted. तो after क्या happen? What happen? कि electrical and magnetic fields are produced, okay, and they transmit. What transmit? तो these fields are transmitted in form of waves. और ये किस तरह से transmitted करते हैं, रिलीज करते हैं emits in the form of wave. तो this wave is known as electromagnetic waves या electromagnetic radiations. Okay, given there ना. So light is the form of radiation. You know about ना, also sunlight, any source of light. Light is the form of radiations. Known है ना, known from early days. Early days हम जान रहे हैं कि light is the form of radiations. And speculation about its nature dates back to remote ancient times. ठीक है, ancient times से है ना move कर रहा है, ये देख रहे हैं. In earlier days, okay, given by Newton, light was supposed to be made of particles. Okay, now you have given that according to Newton's कि light was supposed to be made of particles. क्या है light? क्या है light? Is also made by particles. Okay, corpuscles. It was only in the what? It was only in the 19th century when wave nature of light was established. Or wave nature of light when established in 19th century. Okay, but Maxwell was again the first to reveal that light waves are associated with oscillating electric and magnetic character. But Maxwell what given about light? कि he gives about कि that कि light waves are associated with oscillating electric and magnetic character. किससे ये जुड़ा हुआ है? Electric and magnetic character. Okay, although electromagnetic waves motion is complex in nature. और कैसा nature है? Electromagnetic waves motion is complex nature. This is the so complex, जटिल. We will consider the here है ना only a few simple properties. What is the है ना properties of the these waves particles? Okay, so let's discuss first कि the oscillating electric and magnetic fields produced by oscillating charge particle. क्या हो रहा है कि when the charge particles है ना move during है ना in presence of the electric or magnetic field, then what happen? Are perpendicular to each other. These are perpendicular to each other. Okay, this charge particle, oscillating charge particle perpendicular to both magnetic field and electric field. Understand? To direction of propagation of the wave. और कहाँ पे move करती है? That direction of propagation of wave given there. Understand? This is the z axis, this is the y axis, and this is the x axis. You know about ना? तो when what happens? When charge body, this is the electric field apply है ना? When charge body moves, okay, under the when electric field and magnetic field, okay, created there, then what happens? कि both electric field and magnetic field, this is the electric field, this is the magnetic field, okay, both are perpendicular to each other. Understand? And this is the propagation of wave. Okay, direction of propagation. ये क्या है? This is the direction of propagation. Okay, which waves in propagate? You know about ना? This is the propagation of wave, propagation of the particles wave. Understand? In presence of electric and magnetic component, so both are what? Electric field and magnetic field both are perpendicular to what? Each other. Understand ना? Oscillating charge particles are perpendicular to each other and both are perpendicular to the direction of propagation. अब किस डायरेक्शन में perpendicular थे? In the direction of propagation. Understand? Given there ना? तो in this case what? कि in this case electric and magnetic field both in the direction of propagation, but what happens? Wavelength, frequency, speed, amplitude, okay, all have what? Components all have the same wavelength, है ना? Same, all have the same component, same. In case of wavelength, frequency, okay, what is their wavelength, frequency, amplitude, speed, okay, but they vibrate into mutually perpendicular. But how they vibrate? Mutually perpendicular to each other, both electric field and magnetic field, mutually perpendicular in the direction of propagation of wave. Okay, understand? Second, what is given? Second case, unlike sound or water waves, you know about sound waves or water waves, electromagnetic waves do not require medium and can move in vacuum. Unlike sound, ठीक है, you know about sound or water waves, ठीक है. तो electromagnetic waves don't require medium to move है ना one from to another. There is no requiring medium to है ना move. Just like you know about sound. Okay, sound needed a path. Okay, sound require a medium, a path. Without medium, without path, they can't move sound. Okay, then after we can hear from any voice, any sound particles. Okay, reach to our ear. Understand? So in this way, for water waves and sound waves, require a medium, but in case of the electromagnetic waves, there is not required. Don't require the medium. Understand? They can move in vacuum. Okay, ये vacuum में भी move कर सकते हैं. There is no, okay, there is no any medium. Understand? Vacuum क्या है? There is no any presence of what? Air, water, nothing there. Only vacuum there. Vacuum means empty space. There is nothing presence. Okay, there is no any presence of medium path. Third case, it is now well established that there are many types of electromagnetic radiations. और यहाँ पे कितने होते हैं? Many types of electromagnetic radiation which differ from one and another, जो कि एक दूसरे से क्या होते हैं? Different. Okay, wavelength और frequency. Okay, which wavelength and frequency are different. So these constitute what is the called electromagnetic spectrum. So all these different radiations are occur, electromagnetic radiations are occur which are different from each other. Okay, they are different from one another means their frequency or wavelength are so different. That is known as what? That is known as electromagnetic spectrum. Understand? So different regions of the spectrum are identified by different names, and due to their regions are different spectrum, they move in different ways. Okay, different path. Okay, so identified by different names. Some examples are you know about, that's like a radio frequency. Okay, इसका region कितना होता है? What is their region? Around 10⁶ hertz. You know what is the assigned unit of frequency? Hertz. Okay, so this is the radio frequency. This is also a what? Radiations. Understand? Their wavelength and frequency are different to another. Used for broadcasting. You know about now. Radio waves also used in case of for broadcasting, just like a TV या radio, mobiles. तो ये क्या है? This is the used for the broadcasting. Okay, या telecasting. Microwaves region. Second क्या है? First is the radio frequency. Second is microwaves region. Around 10⁻10 hertz. Its frequency is 10⁻10 hertz. Understand? What is the use? The use for radar. You know what radar? Just like a microwave region, this is the radar. Radar means movement of the any planes. Okay, this is the medium path for movement of the planes. Okay. Third, infrared region. What is the frequency of infrared region? The approx 10⁻13 hertz. ठीक है, this is the frequency of infrared region. Used for heating. What is the use of infrared region? Heating purpose. Okay. And fourth is ultraviolet region. You know about ultraviolet? Okay, UV region. Or you know about now? So UV region, what is their frequency? 10⁻16 hertz. A component of sun radiation. ये क्या होता है UV? You know about UV rays coming from the sunlight, ultraviolet radiation. So many living things affected by this UV rays. Okay, so around 10⁻16 hertz their frequency. So the small portion around 10⁻15 hertz. Okay, and a small portion is there. How many? 10⁻15 approx. What is ordinary called? This is not a what? Visible light. Yeah, visible rays. Okay, their range is approx 10⁻15 hertz. So this is known as visible light या visible rays. Understand? So it is only this part which our eyes can see. तो ये एक ही ऐसा part है. This is the only visible part. Understand? Visible light. Okay, that's we can see easily. Understand? Or detect easily. The special instruments are required to detect non-visible radiations. Okay, and for these non-visible, all just like a UV rays, infrared regions. Okay, so all these radio frequency, so all these waves, radiations. Okay, we can detect by what? By the instrument. Understand? Required to detect non-visible radiation. So we have to use some special instrument. Okay, for detect these non-visible radiations. Understand? So these are the what? Electromagnetic spectrum. Understand? Also we can say these are the parts of radiations. Different parts of electromagnetic spectrum. Okay, types. Fourth, what is the case of fourth? Different kinds of units are used to represent electromagnetic radiation. For the representation of electromagnetic radiation, we use the different units. Okay, there is different units. Just like you know about now. Here is given that these radiations are characterized by the properties, namely frequency. Do you know about the frequency denoted by nu? And wavelength denoted by lambda. Okay, so these electromagnetic radiations denoted by first frequency, lambda, wavelength, and you know about what is the assigned unit of frequency? What? Hertz. SI unit of frequency is hertz. Its unit what? Hertz या per second. SI unit of frequency is hertz या per second. Okay, after that what? Heinrich Hertz. Okay, that's why this call is hertz. B to the he developed the frequency. Okay, so SI unit is hertz. It is defined as the, how can you define its frequency? So it is defined as the number of waves that passes given point in 1 second. Okay, the number of waves, okay, passing in 1 second. Yeah, in 1 second how many, okay, they are passing in 1 second. What is their rate in 1 second? Okay, तो the number of waves at that pass given point, किसी point से क्या हो रहा है, पास हो रही है in 1 second. 1 second में कितना इसका frequency है, okay, कितना waves इसका है, that is known as क्या है, this is known as frequency. Now discuss about the wavelength. Do you know about wavelength? It is represented by lambda. So wavelength should have the units length. Okay, just like we have to measure the length, meter, centimeter. So just like this is also like a wavelength. And you know about the SI unit of length is what? Meter. So same as the SI unit of wavelength is meter. So since electromagnetic radiations consist of different kinds of waves, okay, of much smaller wavelength, smaller units, okay, are used. So various types of electromagnetic radiation which differ from the another wavelengths and frequency, you know about now. So SI unit of wavelength is lambda. Sorry, SI unit of wavelength is meter. Understand? Which is denoted by lambda wavelength. Okay. So in vacuum, all types of electromagnetic radiation, regardless of wavelength, travel. देखिए given there ना, given there कि how can they travel in different radiation and different medium. Okay. These are the given there. This is the gamma rays. Okay, already we discussed in previous topics. Gamma rays, X rays, UV rays, ultraviolet, infrared, microwaves. Okay, this is radio waves, also because of FM and AM. Long radio waves also then. ठीक है, तो above this is measure the above part is measure the what? Frequency, and the lower part is known as measure the wavelength. Okay, lambda meter in meter. Okay, तो you know about ना when frequency is increases then wavelength is decreases. देखिए frequency क्या आ रहा है, increases 10 का power 24, then wavelength what happen, decreases. Okay, both are what? Inversely proportional. If frequency is increases, any spectrum, any radiations have, just like example see here, what is the frequency of gamma rays, what is 10 का power minus, sorry 10 का power 24, its wavelength 10 का power minus 16, मतलब क्या है, lowest. If frequency is highest, then frequency is lowest, lower. Okay, if what, wavelength is higher, just like radio waves, wavelength is higher, then its frequency is lower, just opposite. So this is the relation between the frequency and wavelength of radiation or different spectrum. Okay, तो any radiations या any spectrum है ना, which frequency is lower, then wavelength is higher. If wavelength is lower, then frequency is higher. Here given that na, frequency is higher 10 का power 24, then its wavelength is 10 का power minus 16, so lower. Understand? So this is the case of different types of wavelength. Okay, a wavelength is also denoted by nanometer, given there na. Visible spectrum is also given there, 400, 500, 600, 750 wavelength nanometers. Okay, given by the nanometer, UV light. Okay, ultraviolet and IR. Okay, between the UV rays and IR, visible spectrum there. Understand? तो विजुअल स्पेक्ट्रम रेजिन ओनली ए स्मॉल पार्ट ऑफ द इंटायर स्पेक्ट्रम. तो इसमें क्या होता है, स्मॉल है ना, इंटायर स्पेक्ट्रम में क्या होती है, स्मॉल पार्ट ऑफ विजुअल स्पेक्ट्रम, देन है ना, दैट वी कैन सी इजीली. अंडरस्टैंड? तो दीज आर द वेवलेंथ एंड फ्रीक्वेंसी ऑफ डिफरेंट रेडिएशंस और डिफरेंट स्पेक्ट्रम. ओके, नो प्रॉब्लम. देखिए लेट्स वी डिस्कस अबाउट कि एट द सेम स्पीड हैव गिवन दैट ना, कि वैक्यूम ऑल टाइप्स ऑफ इलेक्ट्रोमैग्नेटिक रेडिएशन रिगार्डलेस ऑफ वेवलेंथ है ना, वेवलेंथ ट्रेवल एट द सेम स्पीड, दैट इज व्हाट इज द स्पीड ऑफ है ना लाइट, यू नो अबाउट ना, 3 × 10⁸ मीटर पर सेकेंड, दिस इज द स्पीड ऑफ लाइट. अंडरस्टैंड? अप्रोक्स है ना दिस मीटर पर सेकेंड. तो एज द सेम ऑल रेडिएशन ट्रेवल इन दैट स्पीड. ओके, इन द है ना स्पीड ऑफ लाइट, सेम द स्पीड ऑफ लाइट. तो दिस इज कॉल्ड स्पीड ऑफ लाइट, यू नो अबाउट, एंड गिवन बाय द सिंबल. ओके, सी, स्पीड ऑफ लाइट इज सी. frequency nu, wavelength lambda, velocity okay of light c. So this is relation okay given by the, this is relation occurs between the where speed of light and frequency and lambda, that is c equal to what, nu into lambda. This is a relation between the speed of light and wavelength and frequency, यानी कि speed of light equal to okay frequency into wavelength, frequency into wavelength, that is the speed of light c. Understand? तो other commonly used as quantity okay especially in spectroscopy है ना, that is known as wave number, is the wave number. Wave number is the also measure the quantity of spectroscopy. It is denoted by v bar. Okay, yeah, nu bar also we can say that as the wave number represented by nu bar. Understand? It is defined as the number of wavelengths per unit length. कि number of wavelength क्या है? What is the number of wavelength in per unit है ना? What is the number of wavelength in per unit length? Okay, per unit length. Its units are reciprocal of wavelength unit. और इसका क्या होता है? wavelength unit का क्या होती है? reciprocal. जैसे क्या है? wavelength SI unit मीटर, तो इसका क्या होगा? per meter. SI unit of wave number is per meter. Because wave number क्या होती है? nu bar equal to 1 by lambda. This is the formula. Wave number equal to nu bar equal to 1 by lambda. So SI unit of wave number is per meter. Thus reciprocal of wavelength. What is the SI unit of wavelength? Meter. Okay. So SI unit of wave number is per meter because wave number is reciprocal of wavelength. Okay. Wave number is reciprocal of wavelength. Understand? So its SI unit are reciprocal of the wavelength, that is per meter. So however commonly used in the in centimeter per centimeter. Also it is not SI unit per centimeter, only meter per meter. Okay. Let's see example here. Given the example problem, the Vivid Bharati station of All India Radio Delhi broadcast on a frequency given there 1368 kilohertz. Okay. Calculate the wavelength of the electromagnetic radiations emitted by the transmitter. We have to find the electromagnetic radiation. Okay, sorry, wavelength of the electromagnetic radiations. Which part of the electromagnetic spectrum does it belong to? जो क्या है? This is the part of electromagnetic spectrum. So we have to find the wavelength of the electromagnetic radiations. What is the electromagnetic radiation? Wavelength of electromagnetic radiation. So do you know about ना? Also you know कि the wavelength lambda is equal to क्या? You know about ना? What is the relation between speed of light equal to nu into lambda? Then we have to find what? Wavelength. So lambda equal to what is? So c by nu equal to lambda. Understand? This is the formula for finding the wavelength. Lambda equal to c by nu. C means speed of light in vacuum by what? Frequency. Okay. So where c is the speed of light of electromagnetic radiation and vacuum. Okay. And v is the, you know about v is the what? V is the frequency here. Substituting the value, you have to substitute lambda equal to c by v. You also know about speed of light is 3 into 10 power meter and frequency given there. After the dividing, calculating them, okay, this is the given in kilohertz. We have to convert into per second. क्योंकि what? Because SI unit of frequency is per second या hertz only. There is what is given there? Kilohertz ना? तो first we have to convert this in per second या hertz. तो 1360 into 10 to the power 3. Okay, after the calculation, we get what? इतना meter. This is the wavelength. 219.3 meter. This is the wavelength of electromagnetic radiations. No problem? Okay, so this is the main formula for finding the wavelength. C upon nu. C is the velocity of light, nu is the frequency. Okay? I hope no problem you have. The second question also given. Understand? 2.4. The wavelength range of the visible spectrum from violet. क्या हो रहा है कि एक wavelength range of visible spectrum radiations extend from violet. कहाँ से ये visible हो गया? wavelength violet से. Extend from violet 400 nanometer to red. Violet से कैसा हो गया ये? red 750. Wavelength is increases, extends. To express these wavelengths in frequency, तो we have to find express these wavelength. इसको wavelength को किसमें करना? convert frequency. That is we have to find the what? Frequency. So that relation you know about ना? What is the relation between frequency and wavelength? So we apply that formula also. Frequency equal to c by lambda. है ना? That same formula you know about ना? What? कि c equal to nu into lambda. So you have to find what? we have to find the frequency. Frequency equal to what? C by lambda. Speed of light by wavelength. So given there, here is the speed of light, you know about 310.8 meter per second and 400 क्या नैनोमीटर गिवन इन वॉयलेट रेज, ठीक है, वॉयलेट मीडियम. तो 4 इंटू 10 का पावर -9 मीटर नैनोमीटर. 1 नैनोमीटर इक्वल न्यू अबाउट ने 1 नैनो इक्वल टू 10 का पावर -9 मीटर. तो सो वी हैव टू कन्वर्ट देम नैनो इंटू मीटर. अंडरस्टैंड? देन इट्स वैल्यू इज 7.5 10 का पावर 14 हर्ट्ज. दिस इज द फ्रीक्वेंसी. ओके, in case of violet range for the violet color. Understand? Now we have to find the red color for red light. So same formula we have to apply. Okay, nu equal to c by lambda. C given there and lambda also given there. 750 meter, so nanometer. So also you have to convert them 10 to the power -9 meter. Okay, then we get what? 4 into 10 to the power 14 hertz. This is the frequency. Okay, so in this way we have to find what is have to find the range of visible spectrum is form itna hertz and itna hertz in terms of the frequency unit. So this in this way, okay, we get the frequency, okay, which are conversion of the wavelength to frequency. No problem. देखिए another question is given there also. Problem given there. Calculate wave number. You have to find the wave number denoted by nu bar. You know about na. B frequency nu of yellow radiations having wavelength given there 800 angstrom. This is the angstrom. So first you know about what is angstrom. The angstrom is also unit of wavelength. 1 angstrom equal to how many meter? So 1 angstrom equal to 10 to the power -10 meter. 1 angstrom equal to 10 to the power -10 meter. Yeah, in case of the centimeter, the centimeter case में क्या होगा? तो 10 to the power -8 centimeter. Understand? Given here. Wave number denoted by nu bar. You know what now? Wavelength given there 5800 angstrom. तो 1 angstrom equal to 10 to the power -8 in centimeter. Meter में 10 to the power -8. So 10 to the power -10 meter. Okay. So we have to find first क्या? Wave number. Do you know about now wave number? What is the formula of wave number? To 1 by lambda. Okay. Then we put the formula. Put in the formula given there. Understand? 1 by lambda. Lambda is given there wavelength. Okay. इतना after the calculation then we get इतना per meter या per centimeter. This is the okay what wave number, okay, of the yellow light. Second we have to find what? Frequency. Do you know about the frequency equal to c by lambda. Nu equal to what? C by lambda. Understand? So c is you know about 3 into 10 to the power 8 meter per second and lambda just we have to find lambda sorry is given in the question what 5800 angstrom mean 10 to the power -10 meter. So 5800 10 to the power -10 meter. After the calculating okay calculation then we get what 5.17 to 10 to the power 14 per second. So this is the what frequency. Okay, so this is the frequency. Then we can easily find the what the frequency of the violet light. What is the frequency of what is the frequency of yellow light, yellow radiation. Okay, so in this way we get the both wave number, okay, and frequency. No problem. I hope you all are understand. Okay.